Welcome to This Explainer. Today, we're diving straight into the fascinating world of C# namespaces. We're going to explore exactly how these fundamental structures rescue developers from the absolute chaos of large, messy code bases. If you've ever opened a project and felt instantly overwhelmed by thousands of files, well, you're in the right place. We're going to break down how to properly structure, scope, and completely master this syntax.
Here's our roadmap for today. We're going to cover organizing the chaos, navigating the hierarchy, the using directive, aliases, and static imports, and then wrap up with some really cool modern C# updates.
All right, part 1, organizing the chaos.
So, picture a massive enterprise application. You're writing your own code, sure, but you're also pulling in multiple third-party libraries. And, predictably, all of these libraries want to use common, obvious class names like logger or timer. Without a system in place to separate them, this would be a total disaster for the compiler. This is where namespaces come in as your organizational mechanism. A namespace groups related types, like classes, interfaces, and structs, under one hierarchical name. Its entire job is to manage complexity and prevent those dreaded naming conflicts. The absolute crucial point here is that namespaces act exactly like a digital folder system on your computer.
Think about it like this. Because mycompany.logging.logger and thirdparty.analytics.logger live in totally different namespaces, or to use our analogy, different digital folders, they can share the exact same class name without throwing a compile time error. It's an incredibly elegant, simple solution to a problem that plagues basically all large software projects.
Moving right along to part 2, navigating the hierarchy.
Now, every single type in .NET has what we call a fully qualified name. Basically, you use dot notation to map out the full namespace path plus the type name. Fun fact, even the standard types you use every single day like string and int are actually fully qualified as system.string and system.int32 right under the hood. When you need a type from an outside namespace, you have to trace the full map, spelling out the entire path to something like myproject.utilities.texthelper just to get there.
And you know, that map can get pretty deep depending on the size of the project. You might start with My Company acting as the root, then step down into a business logic subfolder, further down into a billing subfolder, until you finally arrive at your invoice generator class. This nested hierarchy is absolutely essential for managing thousands of classes in large enterprise apps. It actually allows your code base to perfectly mirror your application's logical, real-world structure.
Next up, part 3, the using directive.
Let's be real for a second. Typing out those massive, fully qualified names every single time you want to use a class is just exhausting. It completely clutters up your code and makes things unnecessarily difficult to read. Enter the using directive. This is a super handy shortcut that you traditionally place right at the very top of your file. By writing using myproject.utilities, you're effectively telling the C# compiler, hey, please just recognize the short names for any types inside this specific folder. It saves you so much repetitive typing and keeps your logic visually clean.
Have you ever wondered what the compiler's actually doing behind the scenes here? Imagine it as a detective trying to automatically resolve a type name. Step 1, it checks the current namespace you're working in to see if the type lives right there. Step 2, if it doesn't find it, it searches all the imported namespaces from those using directives at the top of your file. And finally, Step 3, once it finds a match, it resolves the type automatically. It's a really efficient search protocol.
Part 4, aliases and static imports. But wait, think about this scenario for a second. What happens if two of the namespaces you import both happen to have a timer class? Say you import system.timers and you also import system.threading. Both of these standard namespaces contain a class named timer. If you just type timer in your code, the compiler gets completely confused and throws a compile time error because it has literally zero idea which one you actually meant to use. Well, you can elegantly resolve this conflict by creating a using alias. By doing this, you're giving a highly specific nickname to a single type rather than importing an entire namespace. Now you can use both timers in the exact same file with zero ambiguity. By the way, this is also a brilliant trick for shortening ridiculously long generic type names. Now check out another incredibly powerful tool, using static. Instead of the traditional explicit call to system.math.sqrt, you can just write sqrt of 144. For calculation-heavy files, or maybe a file packed with system constants, using static imports all the static members of a single class directly into your local scope. It drastically cleans up the visual noise. But, and this is a big but, Be careful not to overuse this. If you import too many static classes, your code loses readability because your fellow developers won't easily know where a method like calculate or log is actually coming from. So, putting it all together, you essentially have a complete toolkit for managing scope efficiently. You've got the standard using for bringing in entire namespaces, you have using alias for nicknaming single specific types, and you have using static for importing the static members of a single class directly. Keep this mental framework handy because utilizing the right tool for the right situation will absolutely save you hours of debugging and code review arguments down the road.
Finally, Part 5, Modern C# Updates.
You know, language design is always evolving, and C#10 brought us some massive quality of life improvements to make code even more beautiful and significantly less repetitive. First, we have file-scoped namespaces, which completely eliminate the need for nested curly brace indentation. Second, we have the global using directive. You define this just once in a central global usings.cs file, and it applies project-wide. It literally eliminates the tedious chore of repeating the exact same basic using directives at the top of every single file across your entire codebase.
The visual impact of these file-scope namespaces is immediate. Instead of the traditional way, forcing absolutely everything inside your file to be indented one tab to the right inside curly braces, the modern C#10 way simply uses a semicolon. Notice how this just pulls all of your code straight back to the left margin. It instantly improves readability, reduces nesting, and reclaims valuable screen real estate. Before we wrap up today, I really want you to remember this core truth of .NET architecture. Under the hood, absolutely everything lives in a highly organized folder system. Nothing is truly global. Like we talked about earlier, even basic types like string and int are just helpful C# aliases for system.string and system.in32. Realizing that everything has a specific place is the absolute key to mastering the language.
Which leads to one final question for you to ponder. As your codebase inevitably scales into the thousands of files, how will you design your namespace folder system to prevent future chaos? Think critically about how you structure your own projects right now. Because mastering namespaces isn't just about avoiding compiler errors today, it's the essential first step toward writing truly robust, scalable code for tomorrow. Thanks so much for exploring this with me.